Morning. Today we are going to discuss about BFS. So, what is BFS? So, in one of my previous lectures, I have explained about the knowledge graph. So, its BFS is the traversal algorithms which works on the knowledge graph. Okay, which traverse through the knowledge graphs. So, I will paste the link of the lecture where I have explained the knowledge graph in the description. You can refer that, and on top of that, you can listen this out. So, BFS stands for breadth first search. So you will shortly know why it is called breadth first search. So it's basically a brute force search algorithm which makes sure that every node is visited by the particular traversal algorithm. So this particular traversal algorithm acts as a base algorithm or the start algorithm in the world of algorithms which works on the graph databases. So BFS is the initial one or the base one. So what is this applicability of this BFS? Applicability is that it used for traversing the graph algorithms, traversing the graphs, and then it's explicitly used in the use cases where uh, you have to visit every node. For example, if I relate it to the testing, if you are writing the test cases, so you don't want to miss any particular entities or nodes, so in that case the BFS can be used, is compulsory, and you can just write easy for writing test cases. Now we need to see that how this BFS traversal happens. So consider this directed graph which have A, B, C, D, E, F. There are around 1, 2, 3, 6 nodes. So total nodes are 6. Total nodes are 6. And let's count the edges as well. 1, 2, 3, 4, 5. Total edges are 5. Total edges are 5. Now this BFS works on FIFO principle. So FIFO means first in, first out. So now let's see that how this FIFO will work for this particular graph. So the first set would be an empty set, that would be the step 1. Second would be the first to go would be, for example, would be A. So we have now A present here, so that is the step 2. Now since A is the first one to come in, so then A would be the first one to go out as well. So now A goes out, but if A goes out, what comes in? That is B and C. So B and C comes in, so that is your step 3. Now we have A out and now B and C are there. So after A, the term to go out is B. So now AB is out. So what left is C, but since B went out, so what are the downwards node for B? That is DE. So DE will comes in. So now we have 3 nodes C, D, E. So that is the step 4. Now what is the first node which came in the CD? That is the C. So in the 5th step we have the node out A, B, C. What left is D, E. But since C went out, so what is the input when C went out? That is F. So that would be your step 5. Now ABC is out. What is the next thing which should go out? That is D. So A, B, C, D. What left is E, F. But since D was the last node, so nothing will go in. So this will be your 6th. Now after A, B, C, D, what is the node which should go out? That is E. So it will be A, B, C, D, E. So what left is F. This is your step 7. Now what left which will go out? That is F. So it will be A, B, C, D, E, F, and your array would be empty. So this is the way traversal happens. One thing if you see here, BFS is called level by level search. So for example, you see the first one to go out was A, so that is level. For example, you consider this level 0. Then the next two out go out was B and C. So if you can consider as level 1. And then the next to go out was DEF, so level 2. So BFS goes level by level, and that's why it is also called brute force search, because it search and goes for every nodes. So if you don't want to miss out any particular nodes, and then you can go for this BFS traversal algorithm. Now when we implement BFS traversal algorithm, it's important to know about time and space complexity as well. So what is time and space complexity? So time is basically uh, amount of time taken for traversal, and space is equal to memory memory needed to store the nodes. Okay, so why it is required, why time and space complexity is required? Because when we implement the knowledge graphs, this has to be get executed somewhere, maybe in the machine or maybe in the cloud environment. So if we do not take these things into account, then BFS is infamous for getting out of memory errors. So you can get into out of memory issues. So it's important to know that you understand this time and space complexity. So let's calculate time and space complexity for the previous graph. So here time complexity formula is O is equal to V plus E, and space complexity is O to the power O in bracket V. So O stands for operations, V is equal to vertices, that is your nodes, E is equal to edges, that is your relationships. So now if we need to see how many nodes were here, we had total nodes and 5 edges. So our time complexity would be, time complexity is equal to O 6 plus 5, that is equal to 11. And similarly our space complexity will be number of vertices, that is nodes. So O power 6, that is equal to 6. So this would be our time and space complexity. Let's now calculate this for sample 5000 nodes and 400 edges when you have a machine with 8 GB of RAM. Okay, so let's first calculate the time complexity. So how much time should be required? So for example, you have 500 nodes, so our time complexity formula is O is equal to V plus E, so that is equal to 5000 plus 4000, that is equal to 9000. Now in a 9000 like if a modern CPU has to do a 9000 operation in one go, it should not take much time, it should be over in milliseconds only. Okay, so this is fairly, it is compatible with 8 GB RAM. Okay, 8 GB RAM. And let's calculate the space complexity. Now space complexity, so in the space complexity, memory is being used at two places. First is to hold the visited nodes, second is to hold in queue. Now let's take a worst case scenario that entire uh, we have around 5000 nodes. So if I have created an array of 1 byte, okay, and we have 5000 nodes, and I have to store that in array. So the total space would be required is equal to 5000 bytes, which is equal to 5 KB. So that is quite less, which is required. Now the other space is the memory have to calculate is the queue memory. So when we say visited nodes, I would like to show what we call as visited nodes. So if you see here, we are keeping a check like what is already being visited, ABCD, and there is no repetition of any node. So this is basically your visited nodes, and what get inside this array, for example BC or CDE or DEF, these are the queues like which is in memory, which is still in processing. So if we take that into consideration, for example, we have uh, 4999 nodes are in queue. Okay, so nodes are in queue, or for calculation easiness, let's say 5000 nodes are in queue, and we have a pointer variable which takes around 8 bytes of memory to for 8 bytes of memory for one node. So total for 5000, we would require 5000 into 8 is equal to 40,000 bytes. So in total memory is required is 5 KB plus 40,000 is equal to 45 KB. Now in 8 GB RAM, this would be handled very efficiently, because this is far less what is the capacity of an 8 GB RAM. So I hope this concept is clear. It's very important to know the time and space complexity. I hope this helps. Thank you.